In 2003, 0, we detected methane on Mars. Right? Sound good?
Mm-hmm.
Cool. When I read this, I was like, great, there's methane on Mars, right? Then it says, methane is fragile, that falls apart when hit by ultraviolet radiation. When I read this, I thought, oh, so it must fall apart quickly, right?
Mm-hmm.
So any methane on the Martian atmosphere must have been released into the atmosphere relatively recently. Yeah, I was like, this conclusion makes sense. It was hit by ultraviolet radiation, it falls apart quickly, so any methane that is there, which we did discover in 2003, must have been released into the atmosphere relatively recently. Otherwise, it would have fallen apart a long time ago and be gone, right?
Mm-hmm.
Then it says the argument relies on the assumption. I was like, oh, that means there's a problem. Right? That means there's some sort of gap in reasoning that I must have missed.
Yeah.
Do you see the gap in reasoning?
So, I originally said A, but
Wait, hold on, I don't care about answers.
so I think the gap in reasoning is that the conclusion, which is the last sentence, right?
Mm-hmm.
Doesn't connect to. I don't see how we know for sure it happened relatively recently, and I thought maybe that's the gap in the logic.
Okay, well, it does say it's a fragile compound that falls apart when hit by ultraviolet radiation. As soon as it's hit, boom, falls apart.
But we don't know how often that happens, so
Yes, we don't know how often what happens.
that the methane compound is hit by ultraviolet radiation.
Yes, so what's the assumption that I was making?
That it happens pretty frequently.
What
That
happens pretty frequently?
that ultraviolet radiation or whatever radiation in sunlight hits the compounds pretty recently, or at least frequently enough.
Yeah, like I had assumed that, hey,
This is a
it's in the atmosphere, so it must be being hit by ultraviolet radiation, but that's actually, what do I know about Mars?
Yeah.
Right, I'm kind of bringing Earth's atmosphere into play here, like, well, ultraviolet radiation, that's here all over the place, so it must be all over the place there. But it doesn't have to be, and if there's no ultraviolet radiation, then methane is not being hit by it, and thus not necessarily falling apart. Okay, so you picked A. Mars had no methane in its atmosphere prior to 2003. It's a strong answer.
Yeah, I realized looking back at it that I'm like, oh yeah, we don't necessarily, that doesn't necessarily have to be true, and also you don't know it for sure.
But
What-
what if we negate that? Mars has some methane in its atmosphere prior to 2003.
It doesn't necessarily
It doesn't really do anything to the conclusion because it could have just been hit by ultraviolet radiation and fallen apart. Right? Like, you had, it's just been coming into the atmosphere and falling apart, coming in and falling apart.
Yeah, it
So
doesn't
it
necessarily do anything for the.
Yeah.
doesn't really do anything. Now, the one thing about B is it does have a really strong word, right?
Yeah,
All. Do you know why it's okay?
Because if we negate it, none of them is
Oh, because
exposed.
that falls apart.
We can negate it, but before you even negate it, the strength of the conclusion determines the potential strength of the answer.
Yeah, so it says any methane.
Any methane, which means all methane. So all methane must have been eventually exposed to sunlight and thus broken apart,
Except
and we're good to go. And if you negate it, not all methane is eventually exposed
or
to
none of
sunlight.
the methane?
Hmm?
Not all?
Not all. So the negation of all is not all.
Okay, that makes sense. Yeah.
Yep.
I
So
was negating it as none of the methane.
oh yeah, that's the opposite.
Opposite, yeah.
You want to just negate it, so you're taking the original statement and you're just changing it a little bit, so it's no longer true. But if you change it just a little bit and it's no longer true, and the conclusion falls apart, then that was necessary. If you do the opposite, the conclusion might fall apart for other reasons. Yeah.
Not for the, okay.
Yep. So
So-
all becomes not all.
Is it similar to saying then that methane is not present unless it has fallen apart when hit by ultraviolet radiation?
Wait. What are you saying? Are you saying?
So it's the stimulus of the whole, like, so it says in 2003, scientists detected methane in the atmosphere of Mars.
Yep. Mm-hmm.
And so does that mean that they don't detect methane unless the compound falls apart when it's hit by radiation? Like, there's no methane otherwise, unless it's hit by, unless it's been broken
Yeah, I
down.
think when they detected it, it must not have fallen apart yet.
Okay.
Yeah.
Yeah, I guess I get now looking back at it why B is completely correct, but I think when I was in the moment I was like,
So here's my question in terms of process. Did you read the argument and think it sounded good?
Yeah.
When you saw that it was a necessary assumption question, did you just jump into the answers?
Yeah.
I think that's where your mistake took
Okay.
place. Because, like, I did the same thing. I was like, okay, makes sense, cool. Argument relies on assumption. Oh, there has to be a gap in reasoning. I just thought this argument was good, so I haven't been critical enough
Okay.
of the argument. So then I went back and looked at, like, okay, let me go through these steps. If I accept these premises as true, why don't I have to accept the conclusion?
Yeah.
Oh, maybe it never got hit by ultraviolet radiation, which is what you just said, and that leads us right to B.
Yeah.
Kelly?
I ultimately got this one correct, but it took me longer than usual, in part because when I did that process, I thought of another
Okay, what's
assumption,
another potential problem?
that it can only be detected if it has not fallen apart.
Okay.
And I thought that that wasn't entirely clear because I figured maybe scientists have gotten so experienced / incredible that they can detect something even if it has fallen apart. If that makes any sense.
Wait, so I think you're kind of getting into the premises, maybe, right? Like, wait, what's your exact criticism? Because it says in the first sentence, scientists detected methane in the atmosphere.
Right, so I assumed, I mean, I thought an assumption was that they can detect it. I didn't negate that premise in any way,
Okay.
even though it has fallen apart.
Oh, well, what?
So
There's
they
a
found,
bit.
like trace amounts.
I don't know if that has to be assumed because it's this argument is not concluding that the methane is gone. It's just concluding that it must have gotten there very recently. So the argument doesn't depend on the assumption that this methane is not there, or that it's already broken apart.
Okay, I think I'm gonna have to sit and think about that more.
This is just the last thought. The conclusion is saying any methane must have been released into the atmosphere relatively recently, and so it's very possible that it's still there.
Right.
It's just not been around for a very long time. The conclusion doesn't depend on the assumption that the methane is gone.
Okay.
And it sounds like the assumption you're kind of taking is like, oh, for them to have detected it, they must have detected it after it had fallen apart. But it's not necessarily true that it's fallen apart.
Or just before that violet rays hit the methane.
Maybe they detected it right before it fell apart. But also here, this is saying the conclusion itself is not even necessarily asserting that the methane is gone.
Okay.
It's just asserting that it must have been released relatively recently, and thus not been exposed to ultraviolet radiation yet. Does that make things more confusing?
I'm sorry.
No,
I
we should
started
you should do
this.
25 and then I just need to like ruminate and like ask you what to call again on Thursday.
Okay, think about it. And yeah, okay. So 25.